I would like to introduce Michael Carey, who will be presenting building virtual labs for design validation, technical training, operational migrations. Michael is a senior solutions architect at Converge One and is coming to us today from the State College, Pennsylvania. This is Michael's first time presenting at NANOG, and it's a pleasure to have him speaking with us today. Welcome to the stage, Michael.
Thank you. Welcome. My name is Michael Carey. I'm a senior solutions architect with C1. A little background on myself. I've spent most of my career in higher education and research education networks, and that's how I first learned about the NANOG community and came to participate. This is my first time speaking, but my first NANOG was in Philadelphia in 2006. So it's been a while since I've been back at NANOG, but glad to be back. Two of the themes that really resonated with me, both in the higher ed community and research education, as well as the NANOG community, was really finding tools that we could consider low cost or no cost that really provided some value add to our networks. And categorizing those tools as being easy foot in the door with technology. So hearing presentations at past NANOGs and being able to kind of take an approach that within 2 hours, I could somehow get my foot in the door with that technology and get hands-on with it. And with that, that's why I wanted to bring this presentation to the NANOG community and talk about virtual labs. So let's talk about lab environments. Why have our sandbox and lab environments? Well, we need a place outside of our production networks to be able to test things. That might be new design or new technology validations. We need to give our engineers an environment to test those maintenance windows and write up good method of procedures that they can walk through and test so they know what they're going to be up against. And we also need a footprint to provide a training platform for our engineers. So what's the problem with traditional lab environments? Well, most of the time when people think about them, they're hardware-based and they're expensive to build. A couple years ago, I migrated to more the sales side of the house through a VAR and rarely see customers buying enough equipment to replicate their production environment in a lab. Even if you can afford a true hardware-based lab, they're difficult to maintain. They're usually limited in scope, right? One group at a time is going to be able to touch them. Somebody has to be responsible for that lab, whether it's cabling them up, monitoring them, making sure the equipment is up and running. Once they're up, is somebody really taking it back to a day zero state where the next person can easily jump in? And a pet peeve of mine is the customers that do have them, it's hardware that's running that's just pulling energy and somebody's touching them once or twice every month. So what's a potential solution? Let's look at our network infrastructure that we want to have in that lab environment, but emulate it. So we can build some simulation type environments to mimic our production networks. And we can use those environments for all those initiatives that we talked about. Training our staff, working through migrations and building good MOPs for those maintenance windows, and being able to test new technology or work through new designs without the hassle of having to get physical hardware to do that. So this has been around for a while. I'm sure people have attempted to emulate their networks with a variety of tools that have been out there. A couple of them being GNS3 is one that folks have used. You can install virtual images on any virtual appliance system that you already have. An example of that might be, Juniper has a VMX or VQFX or VSRX that you can just load in there and build the environment within your virtual platform. You can go to the cloud and just spin up some of the virtual network infrastructure appliances to get your hands on with it. But the one I'm going to talk about today is called EVE-NG, and that's the one that I've had a lot of success with recently. So what is the EVE-NG emulation? It's just a next generation tool that's web-based that allows us to implement multi-vendor environments and easily use a web UI to spin up the topologies, work with the configurations, adjust them as needed, share labs, and just work through a simulated environment. So today I'm going to walk through what it looks like to get this platform up and running, give you some tips and tricks, and provide some use cases for some of the successes that we've had with this tool. So there's a couple options when you get into emulating EVE-NG as far as where you're going to install it. The first option would be bare metal, so just taking a server that's available or speccing it specific for this implementation. You can also just install it on your existing virtual machine infrastructure. If you don't have either of those and you have some funding, you can just go out to the cloud. You can install this in Google's cloud platform. And they even have a partner paid option where you can actually pay this company to spin up this environment for you on a time-based basis. The solution I've had the most success with is the bare metal server. The reason for that is because it's isolated resources, and for the labs that I've been working with, I've been able to achieve better performance with that. Here you can see in this example, in the production-facing instance of this that I use for customer initiatives, it's a Dell PowerEdge. It's got 160 CPU cores and 256 gig of memory. We also run a more internal instance of this on a virtual machine, so I have experience with both the bare metal and the virtual. One of the advantages of the bare metal is the ability to utilize what's called cloud interfaces, other interfaces, for a variety of purposes that we'll get into in a couple slides. There's a tool to help you decide on that implementation, and it's called a resource calculator on EVE-NG's website. So you can go here and put in the quantity of nodes that you think you might want to launch in this environment. So let's say you're going to create 10 routers and a couple clients behind them. Based on the vendor that you're going to select, you can put the quantities into this tool, and it'll give you an idea for how much memory and CPU you're going to need to spin up this environment. The next thing you're going to select is what version of the software that you're going to install. So this is one of the best parts. You can see in that first column there called Community, that's the free version of this tool. So no cost to get your foot in the door with it. Even the next step up, which is the professional version, it's less than $200 US per year to get into that footprint. There are some advantages to the professional version. One being your labs are more dynamic, meaning when you create your labs, the topology, the number of nodes that you have, if you want to add links to it or add new nodes to it, you can just dynamically add them in. With the free version, you do have to shut everything down, build your physical topology, and then start up all your nodes again. So it's more of a time-consuming decision that you need to make. There are also some tools that are included in the professional version that we'll talk about that have another advantage. Oh, whoa. Sorry, that jumped on me quite a bit. Let's see if I can go back. Okay. The installation. So when you go and do the installation, you're going to download the ISO specific to that version that you were chose to download, the free version or the professional. Just follow the documentation. It's really good. It shouldn't take more than 45 minutes to an hour to do the install, depending on the platform that you're installing it on. It will run all the security and updates for the underlying Ubuntu as well as the software that it needs. One of the major decision factors in the installation is what physical interface you're going to use to map what's called ETH0, which is Cloud Zero in the platform, for your connectivity. And this interface kind of serves two purposes. One, it's the where you're going to put the IP address to manage that server, and this is where you're going to log in to build all your labs. The other function of this interface is it really becomes that user gateway to all the virtual nodes that you create. So what's going to happen is each virtual node that you create is going to get assigned a dynamic port, and you're going to use that IP address and that port to access these virtual systems. This diagram is an example of how we're using this in a more production customer-facing environment where I've got it behind a firewall. I'm doing some port forwarding and port filtering specific to logging into the server to build the labs, but also give access to these virtual nodes to others. Another note on that interface mapping, when you do the installation and you complete that first reboot when the software is completed, if you have multiple NICs in that physical server or even your virtual installation, the software may choose a different interface after the reboot for that main ETH0. If it does that, you'll find that you'll lose connectivity to the internet and the program won't work. Just note that there's a script that you can run to reorder the NIC after that first installation, and it'll hold after that. It's just that first step in the installation where you may encounter this issue. Those other interfaces that I mentioned, there's a variety of things you can do with that. For example, let's say that you want to have more of a secure environment off those other interfaces to manage the images that are uploaded to that server. So here in this diagram, I've got more of a secure inside access, and I'm restricting that and using that to upload the node images to that server. Let's say you also have it in more of a production environment and you want to monitor that server through another interface. This is another way to do that. Couple things you want to monitor on your server because it will affect how the labs run. The most important things are the CPU usage, the disk space usage, and the memory usage. You'll find the more labs that are launched and the more nodes that are spun up, it'll start to affect your server, and that's very specific to the images and the nodes that you're installing. So it's good that when you build the server to link it into some type of NMS. The other things you can do with those other physical interfaces is you can tie them into more of the physical world that you know of and work with today. So for example, let's say you want to get your foot in the door with Ansible. You can build an Ansible server in this environment, but then you're going to want to pull down the Ansible modules, and maybe you've already started to work with a good footprint of playbooks that you have up in GitHub or GitLab, and you want to be able to pull those down. So wherever you can put those other physical NIC connections into, you can connect to the internet, for example, and pull those directly into this virtual environment. Another example is all of the Juniper equipment that's now capable of talking to the Mist cloud for management and support. You can pull your management interface from the logical lab, tie it to the internet, and start working with the Mist cloud to start working with this equipment. This is a recent example of how I had to tie the physical world that I couldn't simulate into a virtual environment. So if anyone's familiar with Cradlepoint routers, you can't simulate the Cradlepoint OS today and the function of having both broadband and carrier-based circuits. So here what we did is we took another interface off of our EVE-NG server, just tied it into a switching environment where we then had physical links to actual Cradlepoints. And then what we did is we virtualized everything that we wanted to show on both the behind the Cradlepoint and in front of the Cradlepoint. So things like different networks, different clients on the inside. On the outside, tying it to a route reflector so we could walk somebody through and showcase how you would configure routing, for example. And as you're building your server, just common sense and reminder, always have a design guide that you're building along the way, documenting your interfaces, passwords, where you're installing it, along with some type of topology as built. So you're not the only one that has to support this going forward if others do start to utilize it. So once you've installed the software, you've got your server up. Now what you need to do is you need to add the images for the nodes that you want to work with in this environment. So this is called your image repository. Really good guide on how to do this. It's very easy. Just follow the instructions. They're at this web page. You'll see when you go here, there's multiple vendors. It's probably every vendor that everybody in the room works with that you have an opportunity to simulate right now in the system. So 4 basic steps. You're just going to create a folder at this location. You're going to name that folder with the proper context pattern that we'll see in a table in a second. And what that does is that just links the template that's underneath in the software to the image that you want to run. And then you're just going to transfer that vendor's image, whether it's an ISO or in most cases a QCal2 file, and rename it based on those instructions. And then you just run a script that's called fix the permissions. So what does that look like? Let's say I want to simulate a Juniper SRX firewall. So I'm going to create a directory in that folder, and I'm going to call it something specific to what we're going to see in this table in a second. But the last part of that folder name is specific to the version that I'm going to run. And that's because you can run different versions of different software images at the same time. So I'm going to navigate to that folder. I'm then just going to go to the vendor's website and do whatever I need to do to get that image onto that server. If you build that lab like I showed before and that and your server has connectivity to the internet, certain vendors like Juniper, you can actually just download it right from their web page direct to your EVE-NG server using the wget or file save command. Once the file's there, that's when you want to reference this chart in the documentation, and it's got a couple things here. The first column is telling you what the folder name has to start with, and that's what links it to the template that we talked about. The last column is what you have to rename that QCal2 or ISO file to so that the file will run properly when you go to start up the node. So in this case, we're just downloading that QCal2 file from the vendor website. We're renaming it to what it says in the chart. And then we just run this script that's changing the permissions on it so the software can actually utilize that file to run the node. So now we've got our server up and running. We've got our first image in there. So now what we're going to do is we're going to log into the web-based portion of the system and start building these virtual labs. You'll see that you have 3 options when you log in to the web UI. Native console means as you launch and connect to these nodes that you're creating, you're just going to utilize the native applications on your desktop to access them. So, for example, that might be PuTTY or Secure CRT when you're telnetting to the box, or your RDP client if you're RDPing to a virtual desktop. If you don't have those, the next option is the HTML5 console option. And this is just a clientless solution that uses a Guacamole engine to launch that connectivity within the browser for you. The third option is called HTML5 desktop. And what you're doing there is you're accessing an integrated Docker desktop that's pretty much doing the same thing that the HTML5 console option is doing. There's one benefit of that third option. is you can actually transfer files from your desktop into this virtual environment and back and forth as well. So two things that may be useful for are, let's say you have very large configs that you want to get onto these virtual appliances in your environment. You can just move them up there and then TFTP them to the device. The other reason might be maybe you're trying to simulate something in the production environment and you get it built in this lab and you're doing Wireshark captures and you want to get that PCAP file to the vendor. You can pull it out of this environment and then have it as a physical file to utilize elsewhere. So the next step is you actually create the lab topology that you're going to work with. This is nothing more than you'll have a blank space, you name your lab, and in most cases you're going to work with the node and network options that you see here. You just right click on that blank space, go to add the node, and then you're going to add the various nodes based on that list there. The only thing that will populate in that node list are devices that come with the software out of the box or those repository images that we added in the last step. Just note that there are some images that actually require two nodes to work together. For example, the Juniper VMX and the Juniper QFX need both the RE and the PFE images. You link them together and then you start up both of them. Once you add the nodes, then it's just creating your logical topology connectivity between them. So this is nothing more than just dragging between the images that you've created to create those links. By default, the different vendor images will come populated with various numbers of interfaces. Just know that you can increase that. Once your nodes are there and your links are there, then you're going to go actually start up those nodes. So that's going to be nothing more than just, you right click on the node, you click start, it launches it just like a physical hardware would start up. When you do that in the professional version, what's going to happen is the software is going to dynamically assign a TCP port to then access that node. Depending on what type of node it is, you're then either going to reach it through Telnet, VNC, or RDP. In most cases, if you're working with network infrastructure where you're going to be on a CLI, Telnet is what it's going to provide to you. There are certain applications that I've seen drop you directly into VNC, things like the Apstra data center tool is VNC based. Aruba's ClearPass is VNC based. And then a lot of desktop simulation is just going to be RDP based. Just note that anytime you stop that node or wipe that node, which is taking it back to a day zero state, it's going to change that port number. So unfortunately, there's not a good way to grab those port numbers and then keep track of them because that situation will occur on any server reboot or individual node start or wipe. So what does that look like? So in this diagram, I've got 6 nodes there. They're all started. They've turned a different color here, blue, meaning that they're up and running. And then when I hover over one of them, what I'm going to see in the bottom left-hand corner of my browser is this link that tells me how to access it. So Telnet, your fully qualified domain name or IP address, and then the port number. If you have your web browser linked to your terminal application, all you have to do is click on this. It's going to open up PuTTY or Super PuTTY or Secure CRT, whatever you use, and drop you right into the CLI of that device. The other way to do it, and maybe you're going to use this to provide the access to somebody else in your organization or a customer, you're just going to hover over that node and get that information and then provide this to them. So here I'm just taking those 3 variables and inputting that into a PuTTY session. As soon as they hit open, it's going to drop it into the CLI. Most of the routing switching infrastructure is multi-access based, meaning if somebody else accesses it, you can be on that same console port and watch what they're doing. So it's really good for training initiatives where maybe you're providing that to a group of engineers, you're working them through a lab guide, for example, and you're just kind of watching to see if anyone's struggling and might need some assistance. So now we've created our labs, we've added our nodes, we've created that topology, we started up our nodes. Now we can start working with our infrastructure and applying configs. Some advanced configuration options to know about with the tool. Kind of going back to that initial decision point of where do we install this. Now that decision is not as critical anymore because now we can do a function called clustering. So regardless of if we did that initial implementation on bare metal or VM, we can add additional nodes by just doing the installation, saying it's a satellite install, and cluster it into our initial installation. The benefit of this is you can offload and load balance labs. Maybe you've got a pretty high intensive lab that you only want to be able to run on a bare metal server that has more CPU and memory. You can utilize this function for that. Another nice feature is the startup config. So this is the ability to create baselines or establish milestones in the tool. This is good for training environments where you always want to drop that day zero config back to, a known good config. Maybe you're doing service provider and you just want to have the interfaces on there, or excuse me, the IP addresses on the interfaces. And then you start there and go right into routing protocols. The other good thing is the milestone part, because if somebody is using this tool to create a good mop for an upcoming maintenance window, and they're kind of working through it, they can save milestones along the way and drop back to that step if they need to kind of start over from scratch at that milestone. Just know that not all images support the startup config within the system. There is a way around it. You can actually trace out on the CLI what lab you're working in, what node you're working in, and get it to that location there. And you can run a commit command that'll save that image in the state that it's in right now. And then anytime you start that up in the future, it'll be at that state. If you follow the instructions for building Linux nodes within EVE-NG, this is the exact same thing that they have you do, or the BIOS router, for example. So it's just a trick to create known good states of devices that don't support the startup config. You're probably going to want to establish a pretty good folder structure if you do this, so you know what state you're always going back to. You can import and export these labs. Just know there's a difference between Community and Professional Edition. It gives us the ability to share labs with each other. It's a good tool for backing up labs and storing them off-site in case something happens to your server. Just know if I share a lab with you and my lab is built using an Extreme Exos device, you still have to have that Exos repository image loaded for it to start up properly in your lab. The professional edition, so some of the features of that, one is Wireshark. So if you're trying to replicate something or you want to understand something a little deeper, you can build that topology, and within the web UI, you just right click on that interface and you can do capture, and it's actually going to launch Wireshark in that Guacamole engine, and you can troubleshoot it there. You can download the file. You can, look at things. It's actually a good tool for teaching somebody how to use Wireshark with a known good traffic pattern that you can recreate. A couple of vendor tips and tricks. So Juniper Networks VQFX, it's, to borrow a term from earlier today, it's a little spicy in EVE-NG. I've found that this is the best combination of the RE and the PFE to get working in there. You can see it's 18x code, so it's a little older. You definitely can't run as many VQFX images as you can some of the other images because of that situation. But there is a knob that they recommend you run to kind of help with the high CPU requirement. That may not be an issue much anymore because earlier this year, Juniper released two new images, vJuno Switch, which is a simulated version of their EX9214, and vJunos Evolved, which is a simulation of a PTX router running the new Evolved system. So I would probably scrap using the VQFX going forward and kind of focus on getting these two to work. The VMX is now end of life, but they are still updating code out there. I think this week I saw you could still run the VMX with 23x code. And the VMX is probably the one I use the most in this environment for Juniper. The vJuno switch will talk to Mist. So if you haven't worked with Mist and you've been interested in it, it's a great way to get your foot in the door with it at no cost. Extreme Networks, their GitHub webpage is really good. They've got an Exos image up there. They recently updated the VOS image. You can now do control plane as well as a limited data plane. Really good if you want to get your foot in the door with their SPBM fabric technology. The other one I use a lot is Aruba HP's switching environment. You can build a lot in EVE-NG with their firmware as well. And the last thing, it's not only about building virtual infrastructure to simulate our environments, we have to have some client simulation behind it. I found the Vios router is really good. It's easy Cisco Extreme-like config. It's good to simulate client connectivity. You can put the VSRX, which is also lightweight, just put it in packet mode to get rid of the security, and you can use that as a client. If you want true user experience, you can put Windows, Linux, Ubuntu. It'll be more of like a desktop environment. And if nothing else, both versions come with a virtual PC, the VPCS. It's good for if you just want to do ping, ARP, traceroute tools, and kind of simulate MAC addresses at the client side. So a couple case studies I want to talk about. We've had a lot of effort utilizing this tool for training, not only training our internal engineers, but external customers as well. One of the biggest successes, I have a lot of conversations out there talking about utilizing EVPN VXLAN in both the campus environment and the data center environment, and kind of replacing the legacy layer 2 flood and learn out there with this new technology. I've found that getting people hands-on with this really helps to sell that solution, that it's a good thing to look at. So we've been able to build pretty large-scale labs in this environment that are using VMXs for spine and leaf. We even dropped some Docker images in there to show how you can use Ansible to quickly deploy greenfield and changes throughout within this EVPN VXLAN environment. We've got Vios routers for client simulation, so both showing, here's what single home versus multi-home look like. And if you put it on a server that's strong enough, in this case, we can run about 20 pods at one time to get people hands-on with this technology. And then once you build your labs, they kind of act as always-on proof of concepts that you can spin up anytime and showcase 5 to 6 things in an hour if you wanted to. This is just an example of the lab guides. We walk them through everything of the building blocks of EVPN VXLAN. You can really simulate, over 95% of the things you would do in production with this tool. The second one is utilizing this tool to develop better MOPs for migration windows. In this case study, we had a customer that had engaged us to add a second ISP to their network. They were running Juniper routers that were running a specific version of code. We built a simulated environment that looked like their network. And not only was it good for our engineer to work through the steps of what it would look like and build a MOP that had good milestones along the way, but to then take that and actually show the customer, here's what's going to happen that night, here's what it's going to look like, here's what you're expecting. So to then use this tool and kind of make them more comfortable with the changes that were going to be implemented. We then were able to export that lab that we built and give that to the customer so they could use that as a training package for their internal personnel going forward with that simulated environment. And that's just an example of what we used it for. So model your network, execute those changes, document the steps, come up with good milestones, and then utilize that to show the customer. The third use case is in new technology and design validation. So not only new designs that you want to implement that you're thinking of changing in your network, but actually new technology that's out there today that you want to get your hands on. So for this, I would encourage you, if you spin up this environment, to work with your vendors and find out what firmware they have and figure out if it'll work in EVE-NG. I've been able to mock up a lot of new designs lately with some of the technology that's listed here. SD-WAN, for example, Juniper Networks recently bought 128 Technologies, and you can put that virtual appliance in this environment, have it talk out to the Mist cloud and do the configuration and be able to, get your hands on the infrastructure and figure out how it's going to work. Aruba's SD-WAN will do the same thing. Vendor agnostic data center tools. Apstra was another acquisition that Juniper made recently. You can actually spin up the Apstra server within EVE-NG, then start to build virtual Juniper devices and run through the entire workflow of what it would look like if you were going to build an Apstra-based data center all in EVE-NG. I talked about my example of EVPN VXLAN deployments, how we've used the training, been really good to get people hands-on with it. Configuration automation, not only Ansible, but the tool that was talked about 2 sessions ago in here. As I was watching that, I was thinking, you know what? I can just spin up a Linux node, download the Python variables or Python tools that were referenced in there. And within less than 20 minutes, I have an environment where I can start working with a new tool that I heard about that was related to config automation and see what it'll do for my environment. And cloud managed designs, with everything that's now being pushed to, it's the single source of truth, and the management and monitoring is going to be cloud-based. How do you get your foot in the door without having to purchase the hardware, build a lab, link it to the cloud? We've seen that you can simulate that in this environment as well. So successes, whenever I talk about something like this, I always like to know, is there any validation that I can find that, that we're doing the right thing here? And I'll give you a couple examples of that. We're starting to see more vendor-based on-demand labs being offered out there. Again, a Juniper example being Juniper vLabs. All you need is a juniper.net account. You can go to vLabs, and the same thing you're going to work with in the cloud that you can reserve for up to 6 hours at a time is the same thing that you can do locally in your EVE-NG instance. They also have Apstra Cloud Labs, which is specific to that data center automation tool, which is a complete separate instance that you can get your hands on. Extreme also has their digital twin option where you can replicate your production environment in their simulated environment, working through the cloud, and just play with that environment through that platform. EVE-NG lab distribution files. So there's certain vendors out there, Aruba HP being one of them, where you can go to their website and actually download these EVE-NG labs right now. It's usually the lab, a lab guide to help you walk through and work through some configuration. You still need their node repository installed, but they're actually giving you the lab to get your foot in the door with their technology. We live in the YouTube world, so just go search EVNG videos, and you'll find some pretty good stuff about what people are doing that's different, tips and tricks, just like this. There seems to be new ones out there all the time. And internal organization successes. We started this utilizing this tool kind of for two functions, both for customer facing as well as getting our own engineers to use it. Excuse me. And we now see a lot more engineers without having to ask them, did you mock it up in this environment? That's like the first thing they think about when they get a new project. Oh, I'm going to mock this up. I'm going to work through it. I'm going to show the customer what we did. So it actually lends to more successful implementations and maintenance windows. And I think the last validation is just the vendor focus on porting new technology into EVNG. The fact that vendors now have like blogs and videos saying you should actually put this in EVNG to get working with it and get your hands on this technology. So next steps, my goal was to kind of show a low cost to no cost value add tool here. Hopefully easy foot in the door technology, take 2 hours out of your day when you have time to see if this will be beneficial for you. Again, very easy. If nothing else, download that free version, load it on a VM, create some vendor topology that you're familiar with, whether it's Extreme, Cisco, Juniper. Just build a small couple node system, put some configs on there, try to replicate something in your environment that's kind of stumped you recently, see if you can get it working in here. And then document those successes. I believe this is a tool that a lot of people have personal success with. And if you take more of like an enterprise organizational approach, you can expand and utilize this to better the organization as a whole. Thank you. We have 3 minutes left. If there's any questions, I'd be glad to answer anything here.
Hopefully just a quick question. I noticed on the slide for the bare metal, it runs on, do you have it running on Ubuntu? Is it pretty Linux agnostic, or will it specifically run better on Ubuntu?
The ISO file that you download will actually install the OS. Okay. So yeah, it's their choice that it's installed on that. Right. Well, hey, if anybody has questions, I'll be around. Would love to talk to you about it. Brainstorm what labs can be developed to help other folks. I know, watching that the RPKI presentation earlier today and seeing the less than 30% adoption rate in the US is something that maybe it's more of a hands-on thing that needs to push people to adopt that. And I think you could replicate this in this environment and kind of spread that lab around.
You mentioned in your presentation that it's a pretty powerful server, but you run. But what are minimal requirement and requirement per one host to run like Juniper VMX or Juniper switch or something like that?
Yeah, so the specs I showed were from a very powerful server that was going to be customer facing. So we put a lot of funding and power into that to make sure it would be stable. But honestly, I mean, you can just grab an old server laying around your enterprise today and see if it'll work. It really depends on how many nodes you're going to run in it. So if you're just going to build, a 4-router switch topology and want to work with that initially, you could probably go with the minimum specs that'll be listed in that cookbook of what their suggestion is, and utilizing that resource calculator to say, the biggest lab I'm going to build is going to be X routers, X switches, X clients, and that'll give you a good idea. But to get your foot in the door, you can probably go with any piece of hardware that's laying around today. Great. Thank you.